Imagine a world where the progress of humanity was dictated entirely by the elements and the limits of flesh and bone. For thousands of years, we were explorers and builders, but we were always tethered to a very short leash. If you stood on the edge of a deep, dark hole in the ground several centuries ago, you would feel the weight of this limitation personally. Below your feet lay the coal and the ore that could forge a new era of history. But the Earth seemed to have a built-in defense mechanism. As soon as you delved deep enough to reach the richest veins of resources, the ground would weep. Water would seep through the walls and floor, flooding the tunnels and turning your ambitions into a cold, dark lake. The struggle against this rising tide was the defining battle of the era. Men and horses worked until they were broken, using buckets and primitive pumps to haul the water out, but it was often a losing fight. Nature had set a boundary, and for a long time, it seemed we simply did not have the strength to cross it. Before the middle of the 18th century, the menu of power sources available to us was remarkably short and unpredictable. You had the wind, which was a magnificent gift when it chose to blow, but it was a fickle partner that could disappear just when you needed it most. You had the power of rushing water, which was constant and strong, but it forced a strict geography upon civilization. If you wanted to grind grain or weave cloth, you had to take your labor to the river. You could not bring the river to your city. This meant that the placement of industry was decided by the landscape rather than by the needs of the people. And then, of course, there was the primary engine of the world, muscle. Whether it was the straining back of a laborer or the steady pull of a horse, this power was limited by the need for rest, food, and the inevitable reality of exhaustion. There was a massive bottleneck in human history. We had the intellect to design great things and the desire to build a more complex world, but we were trapped by a lack of raw, reliable energy. We were waiting for a way to unlock the dormant power hidden in the earth itself. The first true attempts to use steam as a solution to this problem were remarkable feats of imagination, yet they were incredibly clumsy in practice. These early machines were like giant fire-breathing monsters that lived at the mouths of mines. They were massive, expensive, and possessed a nearly insatiable appetite for coal. Their operation was a violent, clanking cycle of thermodynamics. They would fill a huge metal cylinder with steam to push a heavy piston upward, and then they would spray a jet of cold water directly into that same cylinder to condense the steam. This created a vacuum that pulled the piston back down. While it worked, the process was a disaster for efficiency. Think of it like trying to heat your home in the dead of winter while leaving every window and door wide open. Every single time the machine moved, the cylinder had to be heated up and then immediately cooled down. Most of the energy produced by the burning coal was wasted simply trying to get the metal back to the right temperature for the next stroke. Because they were so incredibly wasteful, these engines were only practical in places where fuel was essentially free, which is why they rarely wandered far from the coal mines they were designed to drain. The path toward a better world began with a young man who worked with his hands, making and repairing delicate instruments. He was given a small, broken model of one of these early engines and asked to bring it back to life. As he tinkered with the brass and iron, he became deeply unsettled by how poorly the machine performed. It was a puzzle that refused to leave his mind. He observed that the tiny engine required a massive amount of steam to complete even a few cycles. He realized that the fundamental flaw was the cooling process itself. By forcing the cylinder to act as both a heater and a cooler, the engine was perpetually fighting against its own nature. He spent weeks wandering through the streets and green spaces of his city, his mind churning with the mechanics of heat and pressure. He was looking for a way to let the machine be hot where it needed to be hot and cold where it needed to be cold, without the two states ever having to battle for the same space. His breakthrough came during one of those quiet walks. He realized that he could add a separate chamber, a second vessel, where the steam could be sent to be cooled and condensed. This would allow the main cylinder to stay scorching hot at all times, never losing its energy to a spray of cold water. It was a deceptively simple shift in perspective, but it represented a revolutionary leap in human thinking. By separating these two functions, he created a design that was suddenly many times faster and used only a fraction of the fuel required by the older models. This was the precise moment the world began to pivot. We were moving away from a reliance on the limits of biology and geography and toward an era defined by mechanical potential. The bottleneck was starting to break. However, the transition from a brilliant idea to a working machine is often a long and painful journey through the mud of reality. At that time, the world of metalworking was far from the world of precision we know today. If you wanted a large metal cylinder, you had to rely on the skills of blacksmiths or those who cast heavy cannons. The results were often lumpy and imprecise. If the interior of the cylinder was even slightly uneven, the steam would simply hiss out around the edges of the piston, like air leaking from a bellows. Without a perfect seal, the engine was useless. For years, the project stalled because the manufacturing technology required to build it simply did not exist. The inventor had the blueprint for the future, but he lacked the tools to carve it out of iron. He needed more than just a workshop. He needed a partner who possessed the capital, the industrial infrastructure, and the unshakable belief that this machine could change the fate of nations. When he eventually joined forces with a wealthy and ambitious manufacturer, the project was finally breathed into life. This partner was a man of the New World, who understood that a great invention must also be a reliable product. He saw that for this engine to truly conquer the landscape, it had to be built with a level of accuracy that had never been seen before. They found their solution in the techniques used to bore out the barrels of massive cannons. By applying this same heavy-duty precision to their cylinders, they were finally able to create a fit so tight that the steam had nowhere to go but to work. For the first time, they could manufacture engines that were consistent, durable, and capable of being transported and installed anywhere in the country. This partnership turned a fragile laboratory experiment into the primary engine of a global revolution. One of the most enduring and clever parts of this story is how they actually managed to sell these strange new machines to a skeptical public. Most people in that era had no framework for understanding things like thermal efficiency or the physics of atmospheric pressure. They lived in a world of tangible, living things. To bridge the gap between the old world and the new, the inventor had to find a way to measure the work of his machine in a language his customers could understand. He turned his attention to the most common source of power at the time, the horse. He spent time watching horses working at a mill, carefully measuring how much weight they could move and how fast they could move it. He boiled all that data down into a single, understandable metric. He could then walk up to a factory owner and tell him exactly how many horses his engine could replace. This gave birth to the term horsepower. It was a stroke of marketing genius that we still use to this day to describe the strength of everything from a simple lawnmower to the most advanced supercar. This measurement was the key that finally unlocked the market. It transformed an abstract scientific advancement into a clear economic calculation. A brewer or a mine owner could look at the numbers and see the exact financial benefit of trading in a stable full of living animals for a single, tireless metal engine. It offered something that nature never could: the economics of certainty. An engine did not need to be fed when it was sitting idle, it did not fall ill, and it did not slow down when the summer sun became too hot to bear. It provided a steady, predictable output that allowed business owners to plan for the future with a level of precision that had once been impossible. As these engines began to spread across the landscape, the ripple effects were profound and irreversible. Before this era, the location of industry was dictated by the availability of natural power. If you wanted to run a massive textile mill, you had to go to the rugged terrain where the streams were fast and powerful. But with this new, efficient steam engine, you could decouple power from geography. You could build a factory in the heart of a city, near a busy port, or right alongside a new railroad hub. This triggered a massive migration of people that would forever alter the human story. Small, quiet villages were swallowed up by sprawling industrial cities that seemed to grow overnight. Our modern world, with its dense urban centers and interconnected global trade networks, was born from the realization that we could generate our own power wherever we chose to stand. The impact went far beyond the physical landscape. It fundamentally altered how we perceive the passage of time. Human life had always followed the soft, rhythmic cycles of the sun and the changing seasons. But a steam engine is indifferent to the time of day or the month of the year. It provides a relentless, steady pulse of energy that demands a matching rhythm from the people who work alongside it. The concept of the factory whistle, the standardized workday, and the modern shift system all grew out of this new ability to generate power on demand. We stopped living by the light of the sun and started living by the steady beat of the piston. Over the following decades, the design was polished and adapted until it could do almost anything. The simple up and down motion used to pump water was converted into a smooth, circular motion that could turn wheels and drive gears. This meant the engine could do more than just drain mines. It could spin cotton, grind flour, saw timber, and eventually pull massive trains across entire continents. It became the very heartbeat of the industrial age. For the first time, humanity possessed a source of power that was scalable, portable, and entirely independent of the weather or the limitations of muscle. Looking back, we can see that this advancement was about much more than just the mechanics of steam. It was the moment we transitioned into a world defined by the pursuit of measurement and efficiency. The obsession with extracting every possible bit of work from every unit of fuel paved the way for every energy breakthrough that has followed in the centuries since. Whether we are looking at the engines that power our modern transportation or the massive turbines that keep our lights on, the lineage of those machines leads directly back to that first separate condenser. We are still living in the world that James Watt helped measure and build. We still speak their language of power, and we still strive for that same elusive goal of doing more with less. This massive leap in mechanical power gave us the incredible tools we needed to transform the face of the Earth, construct towering cities, and move goods across the planet at speeds that would have appeared as pure magic to anyone born just a single generation earlier. But as humanity began to master the physical world of iron and coal, a different and more intimate kind of challenge was waiting just over the horizon. While we were learning how to power our great cities and keep the machines running, we still had to find a way to protect the people living inside them from the invisible, ancient threats of nature that no engine could defeat. That wraps up our look at how a single measurement and a clever tweak to the steam engine ignited the industrial age. Moving forward in our timeline to 1796, we will see how the next major breakthrough changed the stakes of human survival entirely. We go from the power of the machine to the power of the human immune system as we explore the story of the first vaccines. If you want to see how we learn to fight the invisible, make sure to join us for the next episode.